morning. Thank you, Francois. This gets bigger and better every time. It is such a delight to be here, and especially amongst this crowd. What I'd like to do over the next hour is tell you about three big stories. I'm going to tell the story of a new industrial revolution, a new manufacturing renaissance. I'm going to tell you the story of how I use this to do something that should not be possible. And then I'll tell you the story of what kind of company is starting to emerge out of this new industrial revolution. And I think this story will touch all of you in some way, at least I hope so. But let me just start by explaining the whole concept of industrial revolutions, why they're so important. These are the themes that we're going to hit, but it's going to start with technology. The technology creates the innovation models, and the innovation models changes the shape of our economy and our globe. And it begins with a tool. The first industrial revolution in the 1700s took a simple tool like this, the spinning loom, which allowed one person to make one thread, and all it did is allowed one person to make many threads. It was simply a multiplier of human potential. When one person could make many threads, they could make more clothes than they needed. And if they could make more clothes than they needed, then they could sell those clothes. And they became a micro factory, an entrepreneur. They became a cottage industry. And that started to move people from the land to production. It started to create entrepreneurship. It started to create roles for women, emancipated women, who could create small businesses in their home. And that was just a little bit of a glimpse of what happened when we replaced muscle power with machine power. Then the foot-powered loom was replaced by a water-powered loom, and that was replaced by steam-powered looms, and those created the industrial city, and those created the factory, and those created the most massive shift in population that we've ever seen in history. You think of factories as being bad, as being polluting and dangerous and dirty, but this is what happened to life expectancy in the heartland of the Industrial Revolution during the Industrial Revolution. It doubled. Life expectancy doubled as people moved from the land to the factory. Now, how is this possible? The land was clean and bucolic. The land was in fresh air out there in the country. And then people moved into these dirty factories, and they lived twice as long. What's going on? And the answer is that as populations gathered around the means of production, as we moved from beasts of muscle to beasts of brain, we concentrated. And when we concentrated, we created the modern city, and with the modern city came the infrastructure necessary to support concentrated populations. And those include fresh water, sewage systems, healthcare, education, medicine. The act of concentrating humanity around the industrial tools required us to invent a new form of humanity, which was one that was well organized, one that could scale. And that's why the population doubled. It turned out that those villages, those little huts in the countryside, the walls were wet. The water wasn't clean. There was no access to medicine, doctors, or education. And those initial cities were dirty, but they got cleaner faster. They scaled in a way that the towns didn't. And that was the first industrial revolution. That one replaced muscle power with machine power. And this is what it did overall to the population, and this is what it did to the global population. And if you care about the two primary factors of species development, that is overall population side and quality of life, basically nothing in human history mattered more than the Industrial Revolution. So everything we hear about, everything that's, the building that we were in last night celebrates of, the Renaissance and democracy and the Egyptians and, the Islamic world, all those things are invisible in this chart of human history. by the key measure of success, which is population and quality of life. Only once we could replace muscle power with machine power, only then, when we could elevate ourselves above the other species, because we were doing something they couldn't do, which is using tools that multiplied our force. Only then did we jump out and become the dominant species that we are today. That was the first industrial revolution. That was muscles to machines. The second industrial revolution was the next step. It was brains to machines, replacing brain power with machine power. And that was the natural next step. And that was not, again, just the creations of the machines itself. It was not the invention of the computer. Instead, it was the democratization of the computer. The invention of the computer was necessary, but it was the moment where we put it on the desktop, where we distributed it, where we made it personal, that really made it effective. Now, I'm not showing a computer here. Instead, I'm picking one particular year. This was 1996, I believe. And I picked this year because it's an example of democratization. This was the year that Apple introduced the Apple Laser Writer, which was the laser printer that came along with the Macintosh. And in that moment, it introduced a concept of desktop publishing. Now, desktop publishing is one of those funny phrases. We think of it all, we hear it all the time. But desktop publishing combines one word, publishing, which was a traditional factory job. Printing plants are as blocks wide. They involve trucks, of paper, ink by the barrel. They involved, unionized labor and huge machines. And then we just put the word desktop in front of it. And suddenly desktop means cheap and easy and personal and distributed and in your home. In traditional publishing, you had to be in the publishing industry. But with desktop publishing, you could be anybody. And that moment, the idea of putting powerful tools in the hands of regular people for free, without permission required, was liberating. It allowed people to consider themselves as publishers. Now, initially, they could only make a few copies. A church newsletter or a flyer for a lost dog or something like that. And it wasn't very attractive because they weren't trained in how to use fonts and kerning and flow and other sorts of publishing terminology. But over time, they learned. And then about 10 years later, we invented the web. And then we have the ability to democratize the distribution as well. The desktop publishing democratized the creation. The web democratized the distribution. And at that point, you could press a button in your browser, and we've all done this, and you press that button in the browser that says publish, and with a click of a mouse, you duplicate the efforts of what used to be an industrial act. We have now basically taken an industry and turned it into a button in the browser. And this has created the explosion of content and creativity that is today's web and social media. And so when we do this, when we push that button, we don't think enough about how amazing it is that we have taken an industry and made it individual. That we have taken something that used to be for the few and we've made it for the many, and we've taken something that used to cost money and require permission and made it free and available to everybody. But that's what happens when you put powerful tools in the hands of regular people. So that notion of taking the industry and turning it into a button in a browser, that's a really powerful movement. And that's what I'm going to show you is about to happen again. So this was paper and words and pictures, and this was sort of media and communications. But now we're starting to do the same thing with physical objects. Once again, the creation of digital manufacturing happened decades ago, much like the mainframe predated the personal computer. And so we've had digital manufacturing for maybe 30 years. But now we're at the moment where we're introducing the word desktop again. Rather than the desktop laser printer, we have things like the 3D printer and other desktop manufacturing tools, CNC, laser cutting, 3D scanning, things like that. So that's the sort of the make the few element. What about the make the many? The left, the desktop, the 3D, prototyping tools can only make you prototypes. 1, 2, 3, maybe 5 or 6. How do you make 1,000,000? And the answer is that much like the desktop publishing created a digital file, which could then be distributed via the web, desktop manufacturing creates a digital file, which can then be mass-produced via the web. How do we mass-produce via the web? And the answer is what we call cloud manufacturing, which is to say that over the last 10 or 15 years, the world's factories have become networked, especially in China. The world's factories have basically impedance matched the tools of the desktop. And I'm showing you a picture here from Alibaba, but that's just one example. You can now, in your home, on your phone, you could do it right now if you wanted to. You could download a file, an app called, let's say, 123 Design from Autodesk. It's free. You could design an object. You could send it off to a service to be 3D printed. Or you could maybe just send it directly to a factory in China to be mass-produced. They take credit cards. They take PayPal. For all I know, they take Bitcoin. And 10 days later, 2 weeks later, a crate will show up at your doorstep, and you have just got robots in China to work for you. And they take PayPal. It's just amazing. It's almost to the point where we have turned the word manufacture into a button in the browser. Now, it's not quite as simple as that. It turns out that there's a lot of complexities in manufacturing, different materials, combining electronics and mechanical elements and supply chain things, and we're not quite there yet. But for simple things, say, motors, things like that, you really can just pull up a browser, treat it like a website, press your button, and suddenly factories in China will work for you. That's very liberating and powerful. It doesn't mean that you can now compete with Apple. It doesn't mean you can make products of that complexity, but it does mean that you can start. You can start to create products. You can start to experiment very cheaply without owning your own factory. Karl Marx famously talked about ownership of the means of production, that the power goes to those who own the means of production. Well, that's us. We now own the means of production. In the same way that we own the internet, that we have access to these extraordinary server farms and cloud facilities that the Googles and the Apples and the Amazons have, we have access to that. Access has become ownership. You don't need to own Amazon Web Services to use Amazon Web Services. In the same way, you don't need to own a car to get a ride. This notion of access to the means of production has become the new power, and it is as politically radical as Marx's model. The difference being is that it's in the many, not in the few. We call this the maker movement. And the maker movement is really just the web meets the real world. It is the same innovation model that created the web, but now taken outside to the world of atoms, not just bits. It is that same entrepreneurial energy, that same can-do, the do-it-yourself movement, the notion of communities, the notion of mass amateurism. Those trends, which have played out for 20 years so effectively on screens, are now playing out with physical objects as well. And as you know, the physical world is a much bigger one. It affects more of our life. This is just a glimpse of the kind of emerging maker spaces. But the truth is that this technology is moving so quickly that the maker spaces don't even matter anymore, because these technologies are now in the schools. They're in homes. They're available in a virtual form in the cloud. Soon they'll be available. Elements of them, like 3D scanning, are available on your phone. And so, as it went from big factories to then little factories, it's now sort of distributed, so it's just in the ether. It's everywhere. Manufacturing, anybody in this room can manufacture, and you can manufacture before you finish the day. And you don't need skills, and you don't need very much money. It's as cheap as anything else on the web. And it's kind of amazing. And the question is not, can you make things now? The question is, what will you make? That's a very liberating question. The same as the question when we saw that publish button in our browser, we now knew we had permission to publish. And the question was, what will you say? And we all had an answer to this. Sometimes it was YouTube, sometimes it was Facebook, sometimes it was Twitter, sometimes it was blogs. We all had something to say because we had permission to say it. And we could say to an audience of 8 billion people if it was important enough or interesting enough or viral enough. And now we have the same thing with mechanical, with physical, with products. You can make anything. What do you want to make? That was over the last 5 or 10 years, those tools have started to emerge. And it started with very simple ones, like the original laser printer was black and white. It's pretty expensive, $6,000. It was relatively slow, but then it got better and became the inkjet printer and beyond. And now we're starting to see the next phase of these tools. We started with the notion of 3D printing, laser cutting, CNC, but they were limited. The 3D printer was limited to plastics, just one color. CNC was too hard to use. Laser cutters were dangerous. And now we're seeing this new trend of tools that are as easy to use as a 3D printer, but have the materials flexibility of a CNC machine. 3D printers are additive. They start with nothing and lay down a layer of plastic. CNC machines are subtractive. You start with a material like metal or wood, and you cut away. Much like the sculpture in the Louvre, you start with a block of marble, and you cut away the parts that are not the sculpture. With CNC, you start with a block of aluminum, and you cut away the parts that are not the gear. And this used to be really hard. People would go to school and learn to be CNC operators. Today, these are tools that my children have to play with. The other mill right here, this is something that we make Christmas decorations with. How is it possible that, that 6-year-olds are doing CNC? And the answer is, it got easy. It just looks like the web. They open up a browser, they download an object, they press go, and it goes. And what you're seeing is that what we're doing is we realize the biggest barrier to these things is ease of use, complexity. And so rather than sort of training people to use old industrial tools, we're making old industrial tools look like phones, look like the web, look like what we already know. We're turning manufacturing into a button in the browser. This here is the one on the right is a desktop CNC machine called the Other Mill that you can just download a file and press print, and it'll create. Starting with 2D objects and now 3D objects, it'll create a metal object that's beautiful, that's reliable, that's accurate, and it costs like $2,000, and soon it will cost less. This does the same thing, but at a bigger scale. And this one right here, which is new, is what's called a 5-axis CNC. And a 5-axis CNC, which is like this, what car factories use, that used to cost $1 million, now costs less than $2,000. It is, again, desktop size, and with a 5-axis CNC, you can make almost anything. 5-axis means they can kind of come around to any angle, and you can basically, the beauty of 3D printing is that it was not stopped by complexity. You could imagine something infinitely complex, and a 3D printer could make it. There was no price to complexity. But with physical things, with subtractive manufacturing, there was a price to complexity because it was hard to find the right angles to cut it. And with these 5-axis CNCs, you can do this. You can anything you can 3D print, you can now CNC. And this means you can now work with real materials, with steel and aluminum and wood. And now it starts to get really interesting. We've now moved from the sort of the laser printer to the color laser printer to maybe new materials and the ability to, again, not worry about how it works. It just works. And then what we're seeing is that as the machines get better, we start to get more interested in what exactly they're making, the materials that even the 3D printers are making. And although we started with plastics and then resins, and then we started to play with metals, you couldn't do that on the desktop. And now we're starting to, this one here, prints cells, human cells. You can print biology now. And this one here is using conductive and insulating inks to print electronic circuits. These are desktop machines. These are our Kickstarter projects. But these are machines that are going to be in my children's basement whenever they arrive. Let's say in a year. It's Kickstarter. Who knows? But this is kind of amazing. We now have the ability to print biology. We have the ability to print electronics. We had the ability, of course, to print metals and woods, etc. And these things, which used to be so hard, are now desktop tools that can be used by children. I mean, this is just the beginning. But we now have the ability for children to create objects that involve metals, plastics, electronics, and biology. And this is like science fiction. This is like a Michael Crichton novel. Now, I presume that they're not going to create a new species that's going to destroy us, but they could. And that's really powerful technology. And this stuff is now on the desktop, intended for consumers, and getting increasingly cheap. So that's the maker movement, and that's why it's so exciting. I wanted to kind of move the clock back to 2007 and explain why is it happening now? What's going on? What was the catalyst? And I think 2007 was the key year. 2007, if you were paying attention, was the year that suddenly hardware became interesting. For 20 years, it was all about, so back in the 80s, it was all about hardware, the personal computers and chips and the notion of the basics of Moore's law. And then hardware got boring, and it was all about software. And then suddenly hardware got interesting again. And your question is, what changed? So these are just some of the things that happened in 2007. 3D printing started with the RepRap project and companies like MakerBot. Open source hardware, computing started with the Arduino project, and then things like Raspberry Pi. Sensors, MEMS sensors suddenly became available very cheaply. You started to see them in things like the Wii controller. You could move a stick, and something would move on a screen. Amazing. What's going on there? Sensors. Lego put those sensors in the Lego Mindstorms Robotics Kit and combined it with an ARM processor. And then anybody could play with those sensors. The maker movement began with things like Make Magazine and the Maker Faire. And most importantly, Apple launched the iPhone. What you see here is really a combination of things. These open source projects, Arduino and RepRap 3D printing, these were web communities that started to bring that co-production, the community development to hardware. These products, the Wii and the Mindstorms, were using sensors that originally started in the car industry for airbags. These MEMS sensors, the accelerometers and things like that, they were starting to find that the economies of scale had gotten to the point that they cost just a few dollars and could be made into a consumer product. And Apple saw what was going on these trends and realized that there was an opportunity now to reinvent the phone by incorporating things like powerful processors and sensors and turning a phone into a computing platform. And when Apple did it, all those trends accelerated. Apple was now driving the enabling technologies, sensors, GPS, cameras, ARM core processors, wireless batteries. Apple, and then Google, and then Samsung, and LG, and HTC, and Motorola, the biggest companies in the world, started to invest billions of dollars into accelerating the necessary technologies for smartphones. And those necessary technologies now started to move faster than any other technology in history. Moore's law is moving faster in your pocket than ever in history. What's going on with sensors? Amazing. What's going on with GPS and cameras and processors? We now have 3 gigahertz quad-core GPU DSP processors in our pockets. These are like supercomputers. And they're available incredibly cheaply, and they're moving really fast. So that moment, that ability to sort of take hardware and software in the cloud and put them together in the form of a smartphone is not only creating great smartphones, but it's creating amazing components that transform adjacent industries. And the real question is, what are those adjacent industries? So for me, the adjacent industry was discovered through Lego. So it's 2007, and we get the Lego Mindstorms, and I have 5 children who are all here, exploring Paris. They're all being raised French for reasons that they in California, for reasons that have to do with the obvious, bilingualism and culture and all this. But so these 5 children are growing up in Silicon Valley, and we want to make them interested in science and technology. So I'm always trying to teach them, and they don't want to be taught, but they like Lego. So Lego comes up with their Lego Mindstorms Kit, and the Lego Mindstorms Kit has sensors and computing, and we make a robot. And the kids are like, that's completely boring. You know, we've seen Transformers. Where are the lasers? Why is this little plastic? It's so slow. And I thought, okay, well, we'll fly an airplane. And so we flew an airplane that flies into a tree. And they said, that sucked. And they say, well, what would be a better flying airplane than a cooler robot? And I said, well, what if the robot could fly the airplane? And they said, show me. And so we literally Googled flying robot, and the first result was drone. And then we Googled drone, and the first result was autopilot. And then we Googled autopilot, and there was a lot of math, so we stopped Googling. And we just built one. And so this is what happens when a dad and his children Google drone or Google flying robot and have Lego Mindstorms. You end up building this, and this is a Lego Mindstorms processor, and this is sensors. This one's a 3-axis gyroscope, a 3-axis accelerometer, and a 3-axis compass, magnetometer. And we just stuck them together, and we wrote a little code. A 9-year-old wrote the code, and we stuck it in a plane, and it worked. It flew by itself. And this plane is now in the Lego Museum in Billund, Denmark, as the world's first Lego unmanned aerial vehicle. And it's kind of weird. As a matter of fact, it's more than weird. It is kind of unnatural that a dad and his kids can create a Lego drone on their dining room table by Googling the word drone. And yet we did. By the way, drones are regulated as advanced military technology. This thing right here is regulated as a cruise missile controller. It turned out that once we did this, we then, people said, that's illegal. And it's like, how can it be illegal to build something out of Lego? And then, sure enough, we looked, and this is considered export-controlled technology. And if we exported it from the United States, we needed to have it under 24-hour closed-circuit television surveillance and have a login book and make sure that no non-US citizens could see it. We put it on the internet, right? Of course. And it's like, wow, we actually weaponized Lego. That's pretty cool. I don't get chills very often. I was the editor of Wired. I've been in the technology industry a long time. I don't get this sort of wham, that's new feeling very often. I got it once when I saw my first web browser in 92. I got it again when I lived in China in 2007 till 1997 through 2001. And I saw, whoa, China's really new. And then I got it for the 3rd time when this thing flew. This should not be possible. And whenever something that should not be possible is possible, and whenever you had a part in it, you have to ask, I don't know what just happened there, but it's really interesting. I'm going to keep exploring and finding out what's going on. How did this become possible? So I set up a website called DIY Drones, and the website was designed really to ask stupid questions in public. So I said, how is this possible? How does it work? How should I make it work better? Tell me about the software algorithms, etc. And people started contributing, and they started creating cool software, and they started creating cool hardware, and they started creating drone technology, and that was amazing. We said, okay, we're done. I had a day job. I was the editor of Wired. They said, this is just a hobby. This is just a community. It's just a side project. But it kept getting bigger and bigger, and the technology kept getting better and better, and this was just happening because it was the right time. Because it was 2007, and everybody who was paying attention realized that something important was happening in these spin-offs of smartphone technology, and it was going to transform adjacent industries. And one of those industries was robotics, and one of the robotics industries was drones. And that the aerospace industry had no idea what was going on. This was not coming out of the aerospace industry. This was coming out of the smartphone industry. And what everybody here realized was that the future of drones was not airplanes without pilots, but smartphones with wings. And that was not going to happen in Boeing or Lockheed Martin or Airbus. That was going to happen in the grassroots. That was going to happen on the internet. The Apple II didn't come out of digital equipment. It came out of the homebrew computing club. That was the maker movement of the 1970s. And the same thing is happening now. The transformative, disruptive technologies are happening not in the big companies, but they're happening out there in the communities, on the forums, in the maker spaces, at homes, because people can. So then it came time to start a company. And so here it is. Here's my first company. People said, we love your technology, can we, but it's too hard, could you just make a kit? So I said, okay, we'll make a kit. So there's our first production line. We pay our workers here in strawberries and juice. Do not put the 6-year-old on quality control. It does not work out well. The parts were mostly Lego parts with some electronic parts. These things were made for me. Motors were made for me by an Alibaba. And this is the product. This is an autonomous blimp kit called Blimp Duino, based on Arduino. Those are pizza boxes. And we learned some important lessons about economics. Number one, charge more than it costs. Number two, don't buy the parts retail if you intend to sell a wholesale. And number three, if this is your assembly line, don't sell out on the first day, because they won't do it again. So we sold out on the first day. They wouldn't do it again, and so I had to find somebody to help me. So I found a guy on the internet. This guy, Jordi Munoz. He seemed really smart. I'd never met him, and he turned out to be a teenager in Tijuana, Mexico. Just graduated from high school. And I said, hey, my kids won't make these anymore. Would you like to help me? And he said, sure. And I said, well, start a company called 3D Robotics. 3D for the air. And he said, okay. And so there's our second production line. And then I thought that was the end of it. I was running the community, and he was soldering boards together. And then he said, I've moved to a larger space. And I thought to myself, wow, I don't know this guy I met on the internet. He seems really good. Look, he's got shelves. That's really pro. And that right there, Rebecca, she's a bookkeeper. And I was like, we have a bookkeeper. That's super pro. And I thought that was the end of it. And then he sends me another picture. He says, so I bought these pick-and-place machines on eBay. And these are pick-and-place. These are robots that make printed circuit boards. And he bought a pick-and-place machine and reflow oven and stencil printers and CNC machines. And it's starting to look like a factory. And I was like, I did not know that you could buy pick-and-place machines on eBay and download the manual from Google, but you can. And I didn't know that regular people could do this, but this is what kids from Tijuana know. If you're going to start Facebook, get a kid from Harvard. If you're going to start a 21st century aerospace company with a factory, get a kid from Tijuana. Because in Tijuana, Mexico, that is the Shenzhen of North America. That's where they know how to make factories. And this is just in their blood. Of course they're going to buy pick-and-place machines on eBay. So then he sent me another picture, and he says, we've opened a second factory. This one's in Tijuana. This one's the clean room. And I was like, she's got a uniform with our logo. And what you can't see here is that one of the things in these factories that's difficult is static electricity and sort of, the electric sparks breaking things. So you have a grounding wristband. And it's a little band around your wrist that connects to the machine to make sure that static electricity doesn't build up. And when I shared this picture with people, they noticed the band and they said, "You chain your workers to the machines? That's so cruel." So around this time, in 2012, I'm still the editor of Wired. Jordi has started to build up these factories. The factories now start to look like this. This is like with no funding. This is just a teenager from Tijuana, Mexico, and a community just working on cash flow. And then we realized it was time to change things. So we created a real company. We raised venture capital. We've raised more than 100 million at this point. I quit my job at Wired, took over as CEO, and today we have, this is half of our buildings. In San Diego, in Austin, Texas, in Berkeley, California. We have factories in Shenzhen, China. We have offices in Australia. We're partnered with ETH. We met Rafael Dandro yesterday. We're partnered with ETH's university in Zurich. And today we're the biggest drone maker in America. 2.5 years after the company was started, we make more drones every day than the rest of the aerospace industry in America combined. How is that possible? I mean, I had to Google drone 6 years ago, and now we're making more of them than all the aerospace companies in the world combined. Now, one of the answers is that our drones cost $1,000 and their drones cost $100 million, and that our drones are for consumers and their drones are for the military. But the more important answer is because we didn't follow their path. Our drones don't take 10 years to develop. Our drones don't carry people, so they don't have to be regulated that way. Our drones are not limited to military use. As a matter of fact, we don't even allow military use. These are our drones. They're the most advanced drones you can buy. They're more advanced than the military drones. The reason they're more advanced is because the users are less advanced. Because our users are children, they're just people who want great video, they don't know how to fly. They don't learn about the technology. They don't care about the technology. All they want is it to just work. And we've turned, in the same way that iPhone turned the complexities of a phone into a single button, we've turned the complexity of a drone into a single button. And we do this with incredibly advanced technology. It's got onboard Linux computers and something like 45 sensors and I think 17 processors. It's got long distance, high bandwidth wireless connections. It's connected to the cloud. It's got a platform stack as complex as Android. We're running programs on the phone, on the drone, and in the cloud simultaneously. It is got artificial intelligence and computer vision and all the cutting edge stuff. And this is a consumer drone that will soon be on the shelves of Walmart. And it's just, when you think about it, this is, of course, the way it works. The first personal computer was the worst computer you could buy, but it was the only computer that you could buy. It was much less powerful than the mainframes of the day. But because people could buy it, and they came up with applications for it, and the innovation shifted to the grassroots, the personal computer became the best computer that you could buy. The exact same thing's happening with robotics and drones. Because these things are serving the many, and because they have to be advanced, because the users are not, the innovation is shifting to the bottom. The aerospace companies can't compete. They don't know how to make a drone for $1,000. They don't know how to make a drone in 6 weeks. They don't make drones with autonomy of this level because their customers are the military, who are built around pilots and operators and checklists and procedures. But ours are based around ease of use. Push a button and magic happens. The secret of Apple is push a button and magic happens. The secret of all great companies is push a button and magic happens. The military and the government doesn't ask when they do a procurement request. The procurement request does not say push a button and magic happens. But that's what people actually want. And when you come from the grassroots, when you come from a consumer orientation, magic is the natural product. So I told you about the origins of the maker movement and how anybody could manufacture. And I gave you an example of how we use that to become a big company. Now, what does this mean for the maker movement? Is it the end of China? Is it the end of traditional manufacturing? And the answer is absolutely not. There's a place for both. There's a place for the desktop, and there's a place for the traditional factory. And this is the curve that I like to show. It shows you basically, as you scale up, you move back and forth between here, meaning local, manufacturing close to the market, and there, meaning typically China, but wherever mass production exists. And when you make one, you do it on your desktop, and maybe you take that to 100. At that point, you just, like me, I couldn't solder anymore. I couldn't get my children to do it anymore. Then you have to outsource it. In that case, you can outsource it at small scale to any number of cloud manufacturing companies that'll make something for you. And if it works, and you sell 1,000 or 2,000, you think, oh my God, that's really important. I need to learn how this is made so that I can engineer it to be made better. So then you need to understand the process. You can't just push a button and let the manufacturing happen. You actually need to understand the factory. And at that point, you tend to bring the manufacturing back close to home so you can integrate your design and your engineering into the manufacturing process to optimize for a product that can be manufactured. And this takes you to the sort of the 10,000s or so. And at that point, now you understand the product, you understand the process, you understand manufacturing, but now the economics start to matter. Now you're competing with other companies, and now shaving off a few % on margin becomes important. And then you shift it back to the low-cost manufacturers, the high-volume manufacturers, and typically in China. And that's a very natural path. There's a place for here, and there's a place for there. And what this means is a new sort of shape of manufacturing, where it's not all going to low cost, or not all local, but a combination of the two as appropriate. I want to show you this picture because this is an example of a furniture factory down the street from me in California. And what it is kind of interesting. There's three elements here. There's one robot here in the front, the Fanuc, and that picks up aluminum blocks. And it puts it in the other robot in the back, that Cnc machine, and that turns the aluminum blocks into furniture. And the guy in the back, Harold, programs the robots. And this is called a lights-out facility. It just works all night with the lights out. And there's only really two jobs in this factory. Once a day, there's a recycling bin over here, and outside of this machine comes these aluminum filings. And once a day, someone has to take the recycling out to the street so it can be picked up by the truck. And somebody has to program the robots. So those are the only two jobs in this factory. You either take out the trash or you program robots. And I think it's a little bit of a metaphor for the kind of economy, industrial economy we're making today, which is either you're going to be a low-wage, low-skilled worker, or you're going to be programming robots. Now and by the way, the number of jobs of programming robots is growing, and the number of jobs for low-skilled workers is shrinking. Automation is happening everywhere, and we can all buy robots for the same price. This facility could happen in China. This facility could happen in Paris. This facility can happen in Silicon Valley. The costs, we have leveled the playing field on manufacturing. It's not about labor. The labor cost of our products is less than 1% right now, and it's shrinking. It's all about automation. It's about time. How do we make things, because everything's automated, it's all made by robots, we don't think about how to make it cheaper, how to make it faster. And sometimes, going back to this curve here, why would you make something close to you? Speed. Close is fast. Short supply chains, nimble, just in time, responsive, small batch. That's fast. When you go out there, it's cheap. And so you now compare the two, fast and cheap. They're both important, and automation allows you to choose. So I wanted to end with just one note about what kind of world are we creating here? What kind of business model? What kind of economic model? And the answer is really defined by these two people. You have Ronald Coase, who you know is the Nobel Prize-winning economist, the father of the theory of the firm. And he said that companies exist to minimize transaction costs. We put people under one roof so they have roles and responsibilities. You know who does what. It's easy to get things done. And Bill Joy over here said, that may be true, but no matter who you are, the smartest people work for somebody else. So Ronald Coase says, you have to have people working for you to get things done. And Bill Joy says, okay, but they're not the smartest people in the world. And so we lived with that. We lived with hiring people who were not the best people in the world for any particular job because we needed to get things done. And this was a contradiction. It was a conflict. It was a paradox. And I think we've come up with a solution to that, which is to say, when you have the maker movement, when you have the open communities, when you have open innovation, you can get the smartest people in the world to work for you and work efficiently when they're not all working under one roof. We call this open innovation. Open innovation is the solution to the Coasean paradox, which is to say that platforms working in communities sharing, giving away intellectual property means that the smartest people in the world will find you. They may not work for you. They may be working for free. They may be working for themselves. Maybe they're part of the ecosystem, but they're working collectively on something you care about. We are an open innovation company. Our software, we give away our software. It's open source. We give away a lot of our hardware designs. It's also open source. We came out of a community, and we're still driven by a community. We're modeled after Android. We're the Android of drones, if you will. And why does Android have 84, 85% of the global market? Because it's an open innovation platform. You can put it on different hardware. You can fork the code. You can write apps. You can add cloud services. Apple allows you to add apps and cloud services, but you're stuck to the Apple hardware. Android took the open innovation model and took it much further, and that's why it's winning. And so what we learned is that open innovation means that people will work for free because they want to, by their choice. We learned that they work faster. We learned that open innovation exempts you from regulatory barriers. Things like open source exempt you from export control. When you give away things, you're not subject to consumer protection laws. You don't have the same warranties and liabilities. You can give away the bits, the software, and charge for the hardware. That's what we do. The customers are encouraged, empowered to be part of the process and give you feedback, make the product better, beta test, help other customers. We find that when we make this technology cheap and easy, that lots of people will improve it and create companies around it. We build an ecosystem. We build a collective of companies and entrepreneurs who are together making the overall platform better. And because it's cheap, the volume goes up. And because the volume goes up, we find more use cases. It's a virtuous cycle. And this is what we do. We turn this ecosystem, we turn this community into something that starts to look like a hierarchy of reward. When they start working, when they contribute, we do things like give them a T-shirt. It's silly, but it says thank you. It says we recognize your contributions. They feel recognized and rewarded. When they work harder, we give them a discount on hardware. When they work harder yet and do more, we give them free hardware. These are little things, but they're very motivating. They work harder. We invite them to our dev meetings. We give them free airfare, hotels, and things like that. And at the end, we hire them. Or maybe they don't want to be hired, and so we just give them stock in the company. And most of our employees today, well, actually not, about half of our employees came out of this process. They started in the community as volunteers. They started moving up this chain, not because they want the T-shirt, not because they want the coffee mug, because they want the recognition, they want the participation. They believed in the project. They thought it was intellectually interesting. By day, most of them worked for Google or Microsoft or IBM. But by night, they worked for this community. Not for me, not for our company, but for their peers, for the community. And as we recognized their contributions and encouraged their contributions and reduced the barriers to entry to their contributions, they became more engaged. And eventually, they quit their job, and they made this their job. And then we hired them. And at that point, we didn't care about what language they spoke, about what education they had, about where they lived. It didn't matter, because they'd already proven their ability to work productively from wherever they are. And this is called, the platform approach to talent. We created a platform, the platform attracted talent, and the talent then made the platform better. And this model of open innovation, of creating platforms for innovation, is how you can harness the best minds in the world. You're not limited to your country, you're not limited to your language, you're not limited to your laws, you're not even limited to your economic model. You create a platform, and innovation happens spontaneously. And your job is to create what's called the architecture of participation. Make it easier for people to contribute. Build SDKs and dev kits and documentation and community management and evangelists and dev meetings and cons and all this stuff. It's all social. It's all social tools to drive technology magic. And that's the secret of community. That's the secret of open innovation. So I'll just end with this one slide. What I've just showed you is 3 centuries worth of different models. The 19th century, the beginnings of the Industrial Revolution, was about the ownership of the means of production. It was a company who owned a factory versus another company who owned a factory. Company versus company. Then, in the 20th century, manufacturing became a commodity. Many people could have access to the factories. And then it was product versus product. And now I think we've reached a stage with open innovation platforms where everybody can make a product. Everybody can manufacture. Everyone has access to the means of production. And now the question is really ecosystem versus ecosystem, platform versus platform, community versus community. Fundamentally, it's moved from an industrial act to a technological act to a social act. The best companies of the 21st century are going to be the ones who understand open innovation, who understand community and platform, who understand that ecosystems win. Not companies, not products, but ecosystems. The ones who attract the biggest ecosystems win because they will innovate faster, cheaper, and better than any one single company can alone. Thank you very much.